Hello students, we have been discussing the topic periodic properties. In your syllabus, there are 5 periodic properties given. Those are atomic radius, ionic radius, ionization potential, electron affinity and electronegativity. Dear students, in the last video, I have given you an outline of 2 terms. One is atomic radius and the one more is ionization potential. And now we are going to see the continuation part of the atomic radius. Okay, so already we have seen what is atomic radius. Can you recognize what is called as atomic radius? Yes, it is defined as the distance between the center of the nucleus and the outermost shell containing the valence electron. அதாவது நியூக்ளியஸ் உடைய சென்டரில் இருந்து கடைசி ஷெல்லில் உள்ள எலக்ட்ரானுக்கு உள்ள டிஸ்டன்ஸ் தான் அட்டாமிக் ரேடியஸ். ஓகேவாம்மா? ஓகே. ஸோ தியரிட்டிக்கலி we have studied the definition of atomic radius, but practically how can we measure the radius of an atom? That should be a question. We have to ask ourselves how to measure the radius of an atom. Dear students, there is no possibility of finding the radius of an atom directly. Directly ஒரு ஆட்டத்துடைய ரேடியஸை நம்ம கண்டுபிடிக்கவே முடியாது, because all the atoms will be existing in molecular form. Atoms எல்லாமே molecular formல தான் இருக்கும். ஓகேவா? Okay, except noble gases, because noble gases are unreactive. அதோட reactivity கம்மியாக இருக்கிறதுனால noble gases alone will be present as atom, whereas remaining all the atoms will be present as molecules. So for such case we have to use the term either covalent radius or metallic radius depending upon the nature of bonding between the connected atoms. ஓகேவா? ஸோ அது மெட்டல்ஸாக இருந்துச்சுன்னா we have to use the term metallic radius. If it is a non-metal, we have to use the term covalent radius. ஓகேவா? ஸோ about that we can see now. The first one is covalent radius. Dear students, you may know what is called as covalent bond. Can you please tell me what is covalent bond? A covalent bond is formed by the mutual sharing of electrons between two atoms. ரெண்டு atoms வந்து ஒவ்வொரு எலக்ட்ரானை மியூச்சுவலாக ஷேர் பண்ணுறதுனால ஒரு பாண்டிங் ஃபார்ம் ஆகுது. That bonding is called as covalent bonding. Okay, okay. Now we can define covalent radius. It is 1/2 of the internuclear distance between two identical atoms linked together by a single covalent bond. Dear students, now let us see this example, hydrogen molecule. Remember, it is one hydrogen atom, it is another hydrogen atom. These two atoms are connected through a covalent bond. Our hydrogen atom okay, so one hydrogen atom is connected with another hydrogen atom by means of a covalent bond. ஒரு covalent bond மூலமா ஒரு hydrogen atom இன்னொரு hydrogen கூட bond ஆயிருக்குது. ஓகேவா? So in this case, it is not possible to separate these two atoms and then measuring the radius of an atom will be difficult. molecule ஒரு ஆட்டத்தை பிரிச்சு அதுக்கப்புறமா radius படிக்கிறது, it's very difficult. So instead of doing that, we have an instrument that is called XRD, X-ray diffraction technique. By using X-ray diffraction technique, we can measure the covalent radius. So this is called as covalent, this is the diameter. Now we can measure the radius. எப்படி radius will be equal to half of the diameter. So இந்த வேல்யூல பாதி தான் radius. ஓகேவா? ஓகேமா. So it is 1/2 of the internuclear distance between two identical atoms linked together by a single covalent bond. And this internuclear distance, what is internuclear distance? This is termed as internuclear distance. ஒரு நியூக்ளியஸுக்கும் இன்னொரு நியூக்ளியஸுக்கும் உள்ள டிஸ்டன்ஸுக்கு பேர் தான் internuclear distance. So this can be measured using the technique called XRD, that is X-ray diffraction technique. Then after measuring the internuclear distance, we can divide the value by 2 so that we'll be getting the value of covalent radius. Okay, va? Okay, ma. So internuclear distance can be determined using X-ray diffraction technique. Now there is a nice picture is given. So these are the atoms of a molecule. It may be hydrogen, this may be also a hydrogen molecule. Then this D is the internuclear distance between the two atoms present in a molecule. Now we can measure the radius. After measuring the internuclear distance, we have to divide the value by 2 so that we'll be getting the radius of individual atom. So this is called as covalent radius. We can measure the radius of a covalently bonded atom in a molecule. So that is called as covalent radius. புரியுதா? Atoms எப்பவுமே தனியா இருக்காது இல்லாததுனால First, we have to measure the internuclear distance of a covalently bonded molecule. Then we can divide the value by 2, so that we'll be getting the term covalent radius. Okay, okay. Similar to covalent radius, we have another term, that is metallic radius, that we will see later. Now there is an example given how to measure the covalent radius of a molecule. Okay, so example, the problem is the experimental internuclear distance is of Cl2 molecule is 1.98 angstrom. What is given? Internuclear distance. Students, for internuclear distance we have to use the term d. D is the distance between two nuclei, so we have written dClCl, and that will be equal to the sum of the radii of two chlorine atoms. So we have written radius of Cl plus radius of Cl, so we can write dClCl, that is equal to 2 into radius of Cl. Okay, now if we need the value of radius of Cl, means RCl, that is equal to dClCl divided by 2. So we know the value dClCl. What is dClCl? That is internuclear distance. Its value is 1.98 angstrom. So 1.98 divided by 2, that is equal to 0.99 angstrom. So 0.99 angstrom is the radius of a chlorine atom. So in this case, we have measured the radii using the internuclear distance. Internuclear distance la paadi value the radius. Okay, like this will be asked many problems, so you have to be very thorough in solving such kind of problems. Okay. Next, for heteroatomic molecule, for example, if it is a hydrochloric acid, HCl, here hydrogen and chlorine are different atoms linked by covalent bond. For such case, we cannot measure the radii using the same method used above. For that, we have to use another term, so that is given by a scientist, a couple of scientists, Stevenson and Skamaker. So they have joined and given an equation that is called as Stevenson-Skamaker equation. Okay, the covalent radius of individual atom can also be calculated using the internuclear distance between two different atoms. In the molecule, if the bonded atoms are different, HCl, HB or HI, in such cases, in order to measure the radii of individual atom, we are using the equation that is called as Stevenson-Skamaker equation. Okay, this is the Stevenson-Skamaker equation, DAB. Here what does DAB means? The internuclear distance between the bonded atoms A and B. Bonding la ulla A molecule kum A atom kum B atom kum ulla internuclear distance tha DAB, that is equal to RA. RA na radius of the atom A plus RB. RB na radius of the atom B minus 0.09 XA minus XB. Here the term X represents the electronegativity. Okay, electronegativity of the atom A, and XB is the electronegativity of the atom B. So this is the Stevenson-Skamaker equation. DAB, that is equal to RA plus RB minus 0.09 into XA minus XB. Okay, don't forget this equation. It's very important, and it is used for calculating the radii of the individual atoms in a heterodiatomic molecule. Okay, Mama? Okay, so as I already told you. Now, by using this Stevenson-Skamaker equation, we have another problem. Okay, let us calculate the covalent radii of hydrogen using the experimental DHCl, that is internuclear distance between the hydrogen and chlorine atom is given, that is 1.28 angstrom, and the covalent radius of chlorine is 0.099 angstrom. In Pauling scale, the electronegativity of chlorine and hydrogen are 3 and 2.1 respectively. So ennalam kuduthirukanga nu paathom appadina internuclear distance DHCl value kuduthachi, that is 1.28 angstrom. Then radius of chlorine RCl vandu 0.99 angstrom. Electronegativity XA vandu 3, XB vandu 2.1. Now we can substitute in the formula. What is Stevenson-Skamaker equation? DAB, that is equal to RA plus RB minus 0.09 into XA minus XB. இங்க ஏங்கிற பிளேஸ்ல நம்ம C எடுத்து, அதாவது higher value இருந்து lower value minus பண்ணணும். Okay, so DHCl is 1.28, then RH நம்ம கண்டுபிடிக்கணும். RCl is 0.09, then minus 0.09 into electronegativity of chlorine is given 3, then electronegativity of hydrogen is given 2.1. So after substituting all these values, we are getting 1.28, that is equal to RH plus 0.909. then RH is equal to 1.28 minus 0.909, that is equal to 0.317 Armstrong. Okay, so this is the method of calculating the radii using the Stephenson-Carmichael equation. Any doubt here? I think there will be no doubt since it is an easiest concept. Okay, okay. So covalent, with this covalent radius completed, now we have to move on to the next topic, that is metallic radius. Okay, it is same as that of the covalent radius, but only a slight difference. It will be studied in the case of metals. Okay, so metallic radius is defined as 1/2 of the distance between two adjacent metal atoms in a closely packed metallic crystal lattice. Crystals உள்ள metals வந்து close-ஆ pack ஆயிருக்கும். So அந்த adjacent அடுத்தடுத்த ரெண்டு metals-க்கு உள்ள distance-க்கு பேர் தான் என்னது metallic radius. Okay, an example is also given, that is copper. The distance between the adjacent copper atoms in a solid copper is 2.56 Armstrong, and therefore the metallic radius of copper. என்ன கொடுத்திருக்காங்கன்னா, இப்போ imagine பண்ணுங்க, இது ஒரு copper atom, இது ஒரு copper atom. So this distance is given 2.56 Armstrong, that is intermetallic distance. உனக்கு metallic radius வேணும் அப்படின்னா we have to find the half of this value. Okay, so 2.56 divided by 2, that is equal to 1.28 Armstrong. Okay, so with this metallic radii completed. So in this video, what are things we have seen? We have seen what is atomic radius, what is covalent radius, how to measure the covalent radius for a homodiatomic molecule, and how to measure the covalent radii for a heterodiatomic molecule. In the case of heterodiatomic molecule, the atomic radius can be calculated using the equation Stephenson-Carmichael equation. What is Stephenson-Carmichael equation? DAB, that is equal to RA plus RB minus 0.09 XA minus XB. Okay, so here XA and XB are the electronegativities of the atoms A and B respectively. Then by using this equation, we have seen a problem. Then we saw what is metallic radius. Okay, okay. So with this, the term atomic radii completed. In the next video, we will see about the Pauling's method to calculate the ionic radii. Okay, thank you.